Let's graph y equals x squared minus 7x plus 10. So this is our first one where we're going to graph a quadratic, and we're going to get lots of definitions out of graphing this. So we're going to graph this by hand using a table of values and take our time. So first thing though is I know this is a quadratic because it's a polynomial function where the highest power is 2. So polynomial function means no square roots, no negative exponents, nothing funny, right? All the powers are whole numbers and the highest power is 2. So to start, I got my little table of values there. I'm just going to write all the x values from -4 up to +5. So those are the x values I'm going to sub in, and then I'm going to find the y values for those x values. All right, so to find the first y value, I'm going to substitute -4 in for x. So I'm going to get y equals -4 squared, because that's going in for x squared, minus 7 times -4 plus 10. And I get 54. So you can just plug that into your calculator. As long as you have a scientific calculator, you should be able to enter that in straight. Then I'm going to plug in -3 in the same way. So it's going to be y equals -3 squared minus 7 times -3 plus 10. Put it on your calculator, and you should get +40. Okay, so I'm just going to write the 40, and now we got 2 points. Now we're going to repeat this again, this time putting -2 in. So I get y equals -2 squared minus 7 times -2 plus 10, and I get 28. Keep on doing this for the whole chart. We'll just go through this really quick. So for -1, I get 18, 0, I get 10, 1, 4, 2, 0, 3, I get -2. When I substitute 4 in, I get -2 again. It's starting to repeat. When I put 5 in, I notice that I get 0. So because I'm seeing this, oh look, these values are starting to repeat, let's take some more values. I'm going to take x values 6, 7, and 8, plug them in, and see if this pattern of repeating keeps going. Okay, so I'm just extending this table of values. When I substitute 6 in for x, I get a y value of 4. When I substitute 7 in for x, I get a y value of 10. When I substitute 8 in, I get a y value of 18. 9 in, I get a y value of 28. So look at all these values that repeat. This is a common characteristics of quadratics. Anytime you graph something where the highest power of 2, you always get to a point where the values start to repeat. So this is an important thing to notice for absolutely any quadratic, is that at some point the y values all begin to repeat. And now we're going to graph this, and we're going to see what this shape looks like. So I'm just going to plot all these points. They're not going to fit. This is way too big. So I'm going to kind of go from 0, 10 is my first one. Then I'm going to plot 1, 4, 2, 0, 3, -2, 4, -2, 5, 0, 6, 4, and 7, 10. The 8, 18 and the -1, 18, those 2 points I think I can fit on my graph. If they don't fit on yours, just plot the points that fit. Don't do any kind of funny scaling to get things to fit. And when I look, I kind of get this maybe like a V shape I can kind of see. So just remember when you graph it, it's kind of nice and smooth graph. So I'm just going to do my best to draw a nice smooth line through all these points. Now, what's good to notice is that this is the basic shape for absolutely any quadratic. All quadratics have this kind of U or V shape, but it's nice and round. And we call this shape a parabola. So if you've heard that word before, parabola or parabolic, this is what it means. So this shape, it might be flipped over, it might be fatter, it might be thinner, but it's always this basic parabolic shape that we're going to be dealing with in this unit. And now we'll just find some different parts of this graph. So first thing we're going to find are x-intercepts. So x-intercepts are where the line crosses the x-axis. So if we look at our graph, there are 2 x-intercepts. I've highlighted them in green. So this is one of the x-intercepts, and it's at 1, 2, 3, 4, 5. So it's got an x value of 5. The other x-intercept is at 1, 2. So for an x-intercept, you don't have to write the coordinates, but when I write my answer, I'm going to write the coordinates. So the coordinates are 2, 0 and 5, 0 because the y value is 0 on both of those points that are on the x-axis. The only thing about that is just remember when you say it's an x-intercept, which we often call zeros, and the reason we call them zeros is because they're the values that make y equals 0. So it's important that you don't actually have to write the coordinates. If you say the x-intercept is 2, it's implied that the y value is 0. If you say an x-intercept is 5, it's implied that the y value is 0. So you could just say it's an x-intercept of 2 and 5, or you can say x-intercepts at 2, 0 and 5, 0. All right, and we're on to the y-intercepts. Y-intercept, like an x-intercept, is where the line crosses the y-axis. So same idea here. When we state a y-intercept, you can just state the value. So here's my y-intercept. I'll highlight it in yellow, and its value is 10. Interestingly, without having to graph this or do a table of values or anything, I can just look at the equation y equals x squared minus 7x plus 10, and that constant value at the end is always the y-intercept for any quadratic. The reason for this is that because a y-intercept occurs when x equals 0, if you substitute 0 in for x, both the x squared and that 7x are going to disappear, and all you're left with is that constant 10. So let's just take a quick look at the table of values again, and I've highlighted the y-intercept and the two x-intercepts on there, and you can see the y-intercept is when x equals 0 and the x-intercept is when y equals 0. X-intercepts we often call zeros, y-intercepts we just call y-intercepts. There's no special name. So here for my y-intercept, to state the answer again, I'm going to list the coordinates. But if you say to someone the y-intercept is 10, they assume that the x value is 0. So you don't need to restate that. Every parabola has this U shape, so that means anytime it has like a U shape, which we call opening up, that's a parabola that's opening up, it would have a lowest point. A parabola that's upside down, which we would call opening down, has a highest point. So the highest or lowest point we call the vertex. So in our parabola, here is the vertex, which is at the bottom, and it's the lowest point. Counting the x values, we can see that this parabola's vertex is in between 3 and 4, so it's probably at 3.5. We always know it's going to be dead on. It's halfway. The way that the values start repeating, it's always going to be that halfway point. So to find the y value, because we actually want to find the coordinates of the vertex, I'm going to take 3.5 and sub it into my calculator for x. So I'm going to go 3.5 squared minus 7 times 3.5 plus 10. Okay, instead of using the squared button though, I'm just going to go 3.5 times 3.5, which is 3.5 squared, minus 7 times 3.5 plus 10, and there's my y value, negative 2.25. So the vertex has coordinates 3.5, negative 2.25. Okay, next definition is the axis of symmetry. So symmetry means it's like the same on either side. So an axis of symmetry for a parabola is a vertical line that basically cuts the parabola in half, but it's what we say is that it's a vertical line that the parabola is symmetrical around. So basically the right side and the left side are mirror images of one another. The way it works is that for any parabola, if you draw a vertical line through the vertex, that is the axis of symmetry. So here's my vertical line. I'm dotting this red line in. That is the axis of symmetry. The left side of the parabola is the mirror image of the right-hand side. The equation of the axis of symmetry is always x equals the x value of the vertex. So the x value of the vertex here is 3.5. So the axis of symmetry has the equation x equals 3.5. It's really important that you say x equals. If you just say axis of symmetry is 3.5, that's not an equation, that's not a line. The x equals makes this an equation. It makes it an actual line, not just a value. So you got to make sure you put in that x equals 3.5. So there's the axis of symmetry, and I'm just going to write my vertex down below as well. So the vertex was 3.5, negative 2.25. And now on to domain and range. range, which hopefully you remember from grade 10. So domain are the x values of the parabola, or that the function covers. It's all the x values that are possible for the function. The range is all the possible y values for the function. So in this case, and for absolutely every parabola, it's going to go to the left forever, it's going to go to the right forever, so the domain is always all real numbers, which you can just write out the words all real numbers, or if you want, you can use the symbols where it has x is an element, which is that little round e of the real numbers. The real numbers, the symbol is an r with like a double slash. The range is the y values, like we said, for the function. And the range for every parabola, because there's a highest or lowest point, it's never all real numbers. So we always have to find it, but it's based on the highest or lowest point. So the lowest y value is negative 2.25, and then the parabola basically goes up from there. So as you go up, all the y values get bigger and bigger and bigger. So any y value has to be bigger than negative 2.25, because negative 2.25 is the lowest or the smallest y value on this parabola. So the range for this is y is greater than or equal to negative 2.25.